Okay, this is section 3.2. We're going to talk about radians, basically, is the main part of this section. In class, we are going to do a little activity to help us out with radians and kind of what it means, but I'm just going to talk about it in context of the text. Basically, what a radian is simply just a relationship from the arc length to your radius. Okay, so that's kind of the idea that we're going to talk about with that. So 1 radian is when your radius is literally the exact same distance as your arc length. So if you find this distance, if you can actually calculate the curve, if that is the same as your radius, that becomes 1 radian. Okay? Now what you're going to end up figuring out in your activity is that there's actually 6.28 or 2 pi radians in 1 full circle. Okay, so that we're going to kind of see that applying it in real life scenario as well with M&Ms, and we're going to kind of deal with that on Monday, but that is the idea of what a radian is. So no different than anything else. If you have a relationship here, now we have maybe seen arc length before. It's just your radius times your angle in radians. If I actually solve for theta, divide by r, your radian measure is just your arc length divided by your radius. Okay, so if I have a problem like this one, a central angle in a central or a circle of radius 3 centimeters cuts an arc of 6 centimeters, what is the radian measure of the angle? All that's saying is that my arc length is 6 when my radius is 3. I just told you the relationship is if they're equal, it's 1. Well, the arc length is twice as long, so my theta, or your how many radians there are, is just your S over your R, 6 over 3. So you end up saying it's 2. The centimeters cancel out. Radians is its own label, and it doesn't really have a measurement attached to it. It's a really nice label that we are able to use in a variety of different ways. So that's kind of what a radius or a radian is. That's the first example that I showed you here. We need to be able to go back and forth between degrees and radians. Now, some of you are going to really like radians. It's going to sink in really quickly, and you're going to do really well with it. Others, you're going to be like, this is stupid. You're going to be thinking, I don't get pi over 4, pi over 6, 2 pi over 3. I just don't get where that's at on a circle. What I want you to do as we're going through this is have your blue sheet out if you have it, and kind of look back and forth between. Okay, 60 degrees is pi over 3, 45 is pi over 4. Also, if you need to, it takes a little bit extra time, you are always able to convert. Okay? 1 full circle. I just told you, 1 full circle, we all know is 360 degrees. Well, it's also 2 pi. And if you actually solve for one or the other, or put them equal to each other, when 2 pi radians is equal to 360 degrees, if you reduce, you get pi over 180. So here's the relationship, our conversion factor that we can do. Here's how I think about this. If I start with 30 degrees and I want radians, what am I going to multiply by? I need to multiply with the radian, or the pi on top, the 180 on the bottom. Okay, so that's why that is how you can have a pi end up. 30 goes into 180 6 times, and you end up with pi over 6. And if you refer to your blue unit circle at 30 degrees, you should see a pi over 6 right next to it. That's how that all works. If I want to work backwards, let's say I give you pi over, let's just say pi over 4, just for the fun of it. Okay, if you have pi over 4, and you want to go back to degrees, I don't know, well, if I look at my circle, I know pi over 4 is 45. How do I get there? 180 over pi. The reason I have pi on the bottom, I need my pi's to cross out. 4 goes into 180 45 times, and that's 45 degrees. So pi over 4 is 45. That's how you can convert back and forth between degrees and radians. Alright? Now, some of them are going to be on your unit circle. Not all of them will be. If you have pi over 5, you have no choice but to convert using the conversion factor. I want to go 2 degrees, so I need the pi's to go away. So I'm going to put 180 on top because I want my degree. I want my pi's to cancel. 5 goes into 180. Let's see, 36 times, so it's 36 degrees. And that's just how you can use your conversion factor to do that. Okay, this next slide talks about common the common angles, the ones you really need to look at, and most of them occur in the first quadrant. So this is going to be quadrant 1. If you look at your blue formula sheet, how do I go there? Well, 0 degrees is going to be 0 radians. That's not a surprise. Okay? 30 degrees. We just did the one on the previous page. 30 is pi over 6. If you do your conversion factor, you will get pi over 6. 45, we actually did that one as well. I said that was pi over 4. But now, how do I get to 60 degrees? Now, if you look at your conversion or your unit circle on the blue sheet, it says at 60 degrees we're at pi over 3. Now, why is that the case? Here's what I want you to kind of think of. From 30 to 60 degrees, how do I get there? It's just twice as large, right? Or 2 pi's over 6's, and that reduces to pi over 3, and that's the pi over 3. Okay? To get to 90, that would be like going 30 once, and then 30 again, which is 3 pi, okay, over 6, which reduces to pi over 2. Okay? You're halfway to 1 full pi. 180 degrees would be like 6 of them, or this is a half a circle, and we know an entire circle is 2 pi, which I almost should write that down there, and we could work backwards. Okay? 2 pi, cut it in half, that gets you to the 180. That's a pi. Cut 180 in half, you get the 90. Pi over 2. All these relationships happen. Okay? And also I could go and use the pi over 2 idea. 2 pi over 2 gets me to 180. A third pi over 2 gets me to 270. If you look at 270, that's 3 pi over 2. So all of these are interrelated. They're all kind of relate on each other, and these are the essential ones that if you are able to memorize these, you're going to hear me rattle them off, the better off you will be. If you can't, we always have the conversion factors and all that stuff. So find the exact value. So if I ever say exact value, you cannot use your calculator. It's not worth your time. You need to set up a triangle and figure out what we're doing. So 5 pi over 4. Where is 5 pi over 4? I know that's past pi. Okay? And actually, how much past pi? That's like saying sine of 4 pi over 4 plus pi over 4. Okay? 4 pi over 4 is just 1 pi. 1 pi is straight to the right. So I know that's like 180 degrees plus pi over 4 is 45 degrees more. If you don't know that, then you need to convert 5 pi over 4 times the 180 over pi thing, and you should end up getting what? 225 degrees. And can you graph 225 degrees? Should be able to. And what you want to do now is, okay, it's a 45 degree or a pi over 4 radian reference angle. So that's what you have to be able to build. And if you can make this as 45 degrees or pi over 4, you know that we have a 1, 1, I lied, 1, 1, square root, oh my goodness. The hypotenuse is the square root of 2. Okay? And it's a -1 and a -1. So what is my sine of 5 pi over 4? It needs to be exact value. What is the y over the r? -1 over root 2. So it's negative square root of 2 over 2 is your exact value. You dumping that into your calculator and giving me a decimal is going to earn you absolutely 0 points on a quiz or a test. I'm going to want you to make me a picture and give me the exact answer. Okay? Likewise, on this next one, it's 2 times whatever the cosine of 2 pi over 3 is. So multiple things can happen. If you have a unit circle, find 2 pi over 3. Okay, on your unit circle, that's 120 degrees. So either you need to know it's 120, find it via your blue sheet, which that's not going to be on your quiz or a test, so you need to kind of figure out or memorize, or convert 2 pi over 3 times 180 over pi. Cross stuff out. 3 goes into 180 60 times. 2 times 60 is 120. So that's a way to do that. Now, why is that helpful? You now are able to draw yourself a picture. 120 degrees. I'm in the second quadrant. My reference angle, if this is 120, theta hat will end up being 60. So that puts square root of 3 here, 1 here, 2 there. The 1 needs to be negative. I want the cosine. Cosine is the x over the r. So just the cosine of this angle is -1/2. Okay? So I know that I need to go 2 times my negative 1/2. And then I multiply the 2. This 2 up front is just the multiplier that you do at the end once you find your relationship. And so you end up getting just negative 1. Okay? Then the last one, 7 pi over 6. Well, I know that 6 pi's over 6 is equal to 1 pi, so that's 180. And I'm pi over 6 farther. So I know I need to go pi over 6 past 180. Pi over 6 hopefully is registering, hey, that's just 30 degrees. So either you write 30 degrees or pi over 6 here. So that ends up making a 1, root 3, 2, left and down need to be negative. And I'm asking for the tangent. So either you make the connection, tangent in this quadrant is positive, or I know a negative over a negative is positive. So I'm going to end up getting negative 1 over negative root 3, multiplied by square root of 3 over square root of 3, and you get negative root 3 over 3 as your exact answer. So there's where you might see some radian measures, and you just have to make the connections, figure out the degrees, build your triangle, and then answer the question like any other section we've done. Here's a more difficult one that you might see, and all they're going to do is tell you what x is. Okay, they're going to actually give you that. So it's 4 times the sine of 2 times pi over 6 plus pi. Okay, so we need to figure out what's in the parentheses, because that's what our order of operations tells us. 2 pi over 6 is like pi over 3 plus pi. That ends up making it 4 pi over 3. Okay, because this could be like 3 pi's over 3 plus 1 is 4 pi's over 3. 4 pi over 3 puts me in the third quadrant, and that's like 240 degrees. So if you look at your blue sheet, it's 240 degrees. Or you could do the conversion factor, however you want to put it. And if I draw myself a picture, 240 degrees puts me down here. My reference angle is going to be 240 is what? 60 degrees beyond 180. So I know that my square root of 3 is here, 1's there, 2's there. I'm down and left. And I need to find the sine of that 240 degree angle or 60 degree reference angle. So it's negative root 3 over 2. So I have 4 times negative square root of 3 over 2. And now if I multiply these together, 2 goes into 4 2 times, and I end up getting negative 2 times the square root of 3. And it's just a math problem where you just got to figure out what you're looking for. Alright, so this one was all about dumping in, figuring out what your angle is inside, making the connection so you can draw your picture, and then doing everything we've done in the last 2 chapters. Alright, so there is your snapshot for radians. Please, please, please do not feel alarmed if you do not grasp the radians right away. This is the assignment that we're going to do in class, and I hope you have a wonderful day.